limit of a function. So function is a function. When we say about a function, so we can always draw a graph. Say y is equal to fx. Then we consider only the real valued function. So this is coordinate system. So x is independent variable, it goes along horizontal line, and y along vertical line. So we can draw this type of graphs for this. These are continuous function. If it is we can draw this type of graph. Say y is equal to, say, x plus 2. So this is a straight line, equation of straight line. So it is of this type. So this is the graph y is equal to x plus 2, like this. So always we can draw a graph of the function. Now when you say so limit of a function, pictorially we describe this as, suppose at this point, suppose this is the function y is equal to fx, its graph is this is the path, it traces this path. So we put the values for x, corresponding values of y, and we can have this. Then at this particular point, so suppose this is the value of x is equal to, say, a, x is equal to a. So when x is having a neighborhood here, so this is for right part and this is for left part, and when x is approaching from negative left side, then the path is going like this. These values are less than a, and when the values are greater than a, then this path y's are coming along this. This path is traced this. So y. So this is the point. Say this is a point. So it is from upward direction. So y's are coming like this. In this case, these are this value. So this is the right side. This is the left side. So from when x approaches towards a from right side, y is coming from upward direction, and when this is from downward direction, it comes to this. So in this neighborhood, what is this y? What y is approaching? So that is the that point we say limit of the function. So this point, it is this one. So this is neighborhood of this point, and when x approaches a, then this is a graph, and this point is approaching. This is here, y coordinate is here. We draw a parallel line, then this point is on y-axis. So y approaches to this point. From left side it approaches to this point. We say limit of fx as x tends to a is this point. So graphically we are explaining this. So theoretically we always consider when x approaches a, means a is limit of x, then we always consider a neighborhood a plus delta and a minus delta. This is a interval. So delta is very small quantity. We say delta is greater than 0. And definition is when x tends to a, means x lies in this neighborhood, a minus delta, a plus delta, then for all this fx belongs to some value. So fx minus L, this is less than some epsilon. Epsilon is also a very small quantity. So here if we say this point is L, then for this neighborhood we can say this is L minus L plus epsilon, and this is L minus epsilon. So fx belongs to, So fx belongs to what? Fx belongs to, it is L minus f, fx belongs to L minus epsilon L plus epsilon. This is belongs to, this is epsilon. So epsilon is a very small quantity. This is the symbol belongs to. So fx lies in this. So for all this, so here we see x is in this neighborhood, then x in this graph, x fx, this fx on y-axis, so in this neighborhood, they are in this neighborhood. So image of this interval lies on here. So graphically we are saying this, that fx is, L is the limit of fx. So this is limit. So means what? X approaches a, but one thing is important, x is not equal to a. We consider x is not equal to a, means it is the deleted neighborhood, deleted neighborhood, deleted neighborhood, neighborhood, neighborhood. So deleted neighborhood of a. X equal to a, at x equal to a, it is not necessary that it has some value at x equal to a. Say for example, it is, say y is equal to x square minus 4 by x minus 2. So here if we write x equal to e, x equal to 2, then there is no meaning. So then y of 2 will be what? 4 minus 4 by 2 minus 2, means what? This value is 0. So at x equal to 2, it doesn't have any value. And don't think that this is equal to, you can cancel. Don't think that you can cancel it to get it x plus 2. When we say about function, then we can write x square minus 4 by x minus 2 as x plus 2. But when we say about function, existence of this function at x equal to 2, it is not having this value, this expression. So they are not same, not same. When we say about function, then they are not same. Means what? When y, x is unequal to 2, unequal to 2, then we say these are equal. But when we say y at x equal to 2, at x equal to 2, then they are not equal. Then x square minus 4 by x minus 2 is not same as x plus 2, because at x equal to 2 we need to write 2 here. This means this is 0 by 0, so we cannot have this one, because we cannot divide anything by 0. So if we draw the graph, then for this we see x, this is the point, say x equal to 2, then this is point, this is where we know this x is equal to 2, it is 4, y is equal to 4. If we say this has x plus 2, so only for the point x equal to 2 it doesn't exist. But when x is less than 2, then our graph is this. When we draw the graph, then our graph is like this one, and here it is a gap. It is straight line, but it doesn't have any trace here. This point is not it doesn't passes through this point, so it is a gap here. So this is the point, this is at 4, this 4 point here, x at x equal to 2, x equal to 2, it doesn't have value, so this point is not on this graph. And this 4, So when x is approaches 2, so we are considering this interval, this 2 minus delta, 2 plus delta. So when x is approaching 2 from left hand side, this approaches 4, and when this approaches from right hand side, this also approaches 4. So the interval is like this. So this neighborhood, the value of for all x lying on this neighborhood except the point x equal to 2, all will be in this interval, 4 minus epsilon, 4 plus epsilon. So we say this 4 is limit of fx. Fx means this function, x square minus 4 by x minus 2 as x approaches 2. So we write limit of x square minus 4 by x minus 2 when x approaches 2. So this is equal to 4. But we cannot write f of 2 equal to 4. We cannot write like this. This is not this is false. It is false. So this we can say about this pictorial explanation. So theoretically, what we do to find limit of a function, what we do, we write x is equal to 2 plus h, because x is not equal to 2. H is some value, very small value. So then we say limit x tends to 2, this is x square minus 4 by x minus 2 is equal to limit, we put x equal to 2 plus h, 2 plus h whole square minus 4 divided by 2 plus h minus 2, and here we write h is approaching to 0. H is a very small quantity, h approaches 0, but h is not equal to 0. Then after simplification we get here limit h tends to 0, then denominator is h and numerator will be 4h minus 4 will go 4h plus h square. So this h will be cancelled out and remains is equal to limit h tends to 0, then it is 4 plus h. So h tends to 0, it is 0, the value is 0, and we write this as 4. Or directly also we can write x square minus 4 by x minus 2. So we can say x minus 2 equal to x square minus 4 equal to x minus 2 whole into x plus 2. Then we can cancel out, because x tends to 2 but x is not equal to 2. If x is equal to 2, then this is 0 and we cannot cancel out x minus 2. 0 we cannot cancel out. Always remember this thing. If there is a factor like this, say 0 into say 6 by 0, we cannot cancel out this. It is not possible. It is not valid. This expression is not valid. We cannot write like this. We can never write 0 in a denominator. So this x minus 2, it is x minus 2 into x plus 2. So we can cancel out, provided x minus 2 is not equal to 0. So x approaches 2 means x is not equal to 0. So this is the thing, because we are this is the thing, this that we are writing this deleted neighborhood. Deleted neighborhood means x is not equal to 2. So to exclude 2 from this interval, and other values will be in the neighborhood 2 minus delta and 2 plus delta. So so this is limit. This is limit. So when we do mathematical calculations, then these are the mathematical calculation, then we write this as not equal to 2, and that is because it is deleted neighborhood, so x is never equal to 2. So this is the main concept of limit. Let's see this thing. So when we do the examples, examples of limit, then it is the we always have to remember these things. Now, so suppose we are to find the limit. So these are some examples. A limit of 5x plus 2, say x tends to say 4, means what? X tends to 4. So this is equal to limit of 5 into limit of x plus limit of 2, and we need to write here x tends to 4, x tends to 4, x tends to 4. So this is constant. Constant means it is always constant. Whatever the value of x, it is always the value 5. So this is equal to 5 into x tends to 4, means we need to write here 4 plus 2, so it is 22. So in this way we find the we do the problems of limit. So for this we are applying this formula, limit of fx plus minus limit of gx. This is limit of fx plus minus gx. X tends to say a, x tends to a, x tends to a. So this is we are applying in then limit of fx into gx into gx, x tends to a, x tends to a. This is equal to limit of fx x tends to a into limit of gx x tends to a, and limit of fx by gx, fx by gx is equal to limit of fx by x tends to a, x tends to a by limit of gx x tends to a. Condition, one condition is here, provided limit of gx x tends to a is not equal to 0. So we are applying these things here. So limit of 5x, it is product. 5 is a constant function, this is x, so limit of 5 into x, so limit of 5 into limit of x, so this is limit of 5 into limit of x. Again this is fx plus minus gx. So 5x plus c 2. So this is limit of this 5x plus limit of 2. So for plus and product there is no problem, plus or minus, but when we say division, that we did one, that we did in that we did in say limit of the previous one, x square minus 4 by x minus 2 as x tends to 2. Here we cannot write is not equal to limit of x square minus 4 as x tends to 2 by limit of x minus 2 bracket should be there as x tends to 2. We cannot write this, but we can write this one, limit x tends to 5 x square minus 4 by x minus 2. We can write this as equal to limit of x tends to 5, this is x square minus 4 by limit of x tends to 5 x minus 2. We can write this one because this is not equal to 0, but we cannot write this one. So this is the limit. Then there is a concept of right hand limit and left hand limit. Means what? We do have a neighborhood. So neighborhood, one part is to the right, one part is to the left. So when x approaches from right hand side, we say it is right hand limit, and if x approaches from left hand side, we say it is left hand limit. So sometimes there may be difference also in case of right hand limit and left hand limit. They are not always equal. Say a function is defined like this. Function fx is equal to say twice x when x is say less than 0 is equal to x cube when x is greater than 0. So domain of, when you say about the graph, so 0 is here, so this is the neighborhood. This is 0 plus delta, this is 0 minus delta. So the neighborhood is minus delta delta, 0 minus delta, 0 plus delta. So when x is less than 0, our path is this cubic function. It is like this. Y is equal to x cube. It is this is like this. And when x is it is for less than 0, it is for less than 0, it is twice x. So twice x is the function. Twice x is the, it is a straight line. So equation is the graph is a straight line. So it is twice x. It is a straight line. And when x is greater than 0, our path is like this. We draw the graph. We can have this like this. And from this diagram we see x is greater than 0, so y is fx is approaching like this, approaching from this, and x is less than 0, then fx is approaching from the negative direction. ultimately it is here. Ultimately this is this. So when we find, say we are to find limit of fx, x tends to 0. So this is in the neighborhood of this. We need to write here left hand limit and right hand limit, because functions are different. Because fx means we have to write about the function. So what we do here, left hand limit of fx as x tends to 0 means what? This is a symbol, limit x tends to 0 minus fx, and in place of fx we will write limit x tends to 0 minus a function we will write 2i6, and as we have done earlier, so it is limit of 2 into limit of x, and limit of x as x tends to 0, it is 0. So it is 2 into 0, this is equal to 0. And right hand limit of fx, x tends to 0, this we write limit of x tends to 0 plus fx, this is fx, and in place of fx we need to write limit, it is x cube to the right part. So x tends to 0 plus, and it is 0 cube, it is 0 into 0 into 0, so it is 0. And we say when right hand limit and left hand limit are equal, so right hand limit equal to left hand limit, they are equal, and this is equal to limit fx, x tends to 0, and the value is 0. So this is the case when the paths are different. To the left it is like this, to the right it is this. Suppose our program function is like this. Say x tends, our function is say so we'll write a different function. Say fx is equal to say x square minus 3 when x is less than 0, and when x is greater than 0 it is say sin x. So this is also a function. So x square minus 3, it is x square minus 3, this is a parabolic curve, and the graph will be somewhat different. But x square minus 3, so to the x is 0, so at x equal to 0 it will be minus 3. So it is like this, x equal to x square, so it is of this type. When x tends to 0, it's x root 3 plus minus root 3, so this is minus root 3. So path is like this, x square less than 0, so it is x is 2 4, it is a parabolic path, so it will be like this. x is less than, so this is the neighborhood, this is neighborhood, so it is -3 somewhere here. So this approaches like this. This is the point -3, and when x is greater than 0, so sine curve, sine path is this, like this. And now we see when x approaches from left hand side, so we write the function from left hand side, it is x square minus 3, and limit of this is 0 0 0 into 0, but this is constant, so this is equal to 0 minus 3 is equal to -3. So we get x is approaching from left, this is the neighborhood, so for this negative x less than 0, so this is the path, and it comes to the point -3, and when it is here, it comes to the point 0. So this is, here you write sine x, sine of x. So sine of x, when x tends to 0, the value is 0. So for this neighborhood, right hand side, right neighborhood, x is approaching to this point, fx is approaching to this point, and when it is in this neighborhood, left neighborhood, this is approaching to -3. Means what? They are not equal. So here right hand limit, left hand limit is not equal to right hand limit, and we say limit doesn't exist, implies limit of fx doesn't exist, x tends to 0 does not exist. We need to write this, does not exist. So this is the way to find limit of a function, right hand limit, left hand limit. So these are the and under concept is there continuity. A function, when we draw the graph, so this function is what? This function is not continuous. It is broken at the point x equal to 0. To the right hand side, it is y is equal to sine x. We can have there, it is continuous to the right part of 0. Also it is continuous to the left part of 0, but at x equal to 0, it is broken. So we say the function breaks at the point x equal to 0, and it is not continuous at the point x equal to 0. So means what? So in the previous example, x square minus 4 by x minus 2, in there also at x equal to 2, there is the graph was broken, because at x equal to 2, the function is not defined. So when we draw a function, if it is broken like this, then suppose this point is a, so we say function is not continuous at a. So it should be like this, it is continuous, so it is continuous at a. So definition is limit must exist, limit of fx, x tends to a, this must be equal to functional value at the point this. Say in the previous case, so x square minus 4 by x minus 2, limit x tends to 2. So at x equal to 2, it is not defined, 0 by 0, it is not defined. So the graph, when we draw the graph, it was like this. This is a straight line, but at the point x equal to 2, it was broken. So it is not continuous. So f2 is not defined. But if we write the function fx is equal to x plus 2, then it is continuous. So this is continuity. So definition is limit of fx. So we find the limit as x tends to a, then fa. Suppose in that case, say fx is equal to x twice x in the previous case, when x is less than 0, is equal to x cube when x is greater than 0. In that case, what we got? So limit exists, limit of function. So left hand limit is 0, right hand limit is also 0. So this limit was 0, equal. But what about f0? Here f0 is, so it is defined only for x less than 0, here x greater than 0. But f0 is not defined. f0 for x equal to 0, there is no value. Not defined. Not defined. So the function is not continuous at x equal to 0. So fx is not continuous at x equal to 0. Now another concept for finding limit of a trigonometric function sin x by x. Sin x by x, will find limit of sin x by x. Sin x is a trigonometric function, and so consider this function fx is equal to sin x by x, sin of x by x. So there is a procedure to find this function limit. So we draw a circle. So this is or geometrically we will write. So this is a circle, this is radius is unity, so this is radius, we extend it here. So this is the center O, this is the point A, then this is a tangent here, this is a tangent AT, and this is the point P, this is angle theta or x, we are saying about x. So POX angle is x. Now x is in radian, not in degree, x is in radian. So if x is in radian, then OA into x is equal to arc AP. OA is, we are assuming this as unity, so OA is equal to 1. So OA is equal to 1, OP is equal to 1. So x is equal to AP, arc AP. Then we draw perpendicular from P to this M on OA. So this is right angle triangle. So PM by OP is sin theta is equal to sin of x, and AT is tangent, so it is perpendicular on OA. So AT by OA is equal to tan theta. So OA is 1, OP is 1. So what we have, AT is equal to tan theta, PM is equal to x, this is x, not theta. So AT is equal to tan x, PM is equal to sin x, and from the diagram we see PM is less than arc AP is less than AT. So PM is sin x, less than x, ap is x, and it is tan x. Then this implies x by sin x. So this you write here x, then less than x by sin x, less than tan x by sin x is 1 by cos x, 1 by cos x. Now here we apply a theorem. Suppose three functions are there, fx less than, or strictly right, strictly less than cx less than hx. If limit of fx x tends to a is equal to limit of hx as x tends to a. So this is gx is lying between fx and hx. We don't know what is the limit of gx as x tends to a, but if they are equal, then we say this implies limit of gx x tends to a is same value. They are equal if we can find the limit of fx and hx. So this theorem we are applying here. So this implies, so from this we have limit of 1 x tends to 0 Homan equal to 1. Then limit of 1 by cos x x tends to 0. So x tends to 0 means cos x tends to 1. So this is equal to 1. This means what? Limit of, we cannot find limit of sin x by x or x by sin x. X tends to 0 because this is 0, this is 0. But because this lower limit is 1, upper limit is 1, so this limit must be equal to 1. So from this we getting a standard result. So this is limit of sin x by x. We are taking the reciprocal. X tends to 0. This value is always 1. So this is our result, and this result has many applications. So this is all about your the concepts of limit. Now we see some examples. These are the examples. So x tends to 3, so it is 2 into x, this is minus 1, so limit of 2 is 2, limit of x is 3, so it is 2 into 3, it is 6, then minus 1 is also constant, so it is 6 minus 1 is 5. So x tends to minus 1, so x tends to minus 1, this is because it is non-zero. So directly we write the values. So this limit is 3 plus 1 minus 5 is minus 1, this is minus 6, so it is 6. This one we see, when we write 3 here, then 3 minus 2 is 1, 4 minus 3 is 1, so 1 minus 1 is 0. So denominator cannot be 0. So we do some calculations. So this is this is a minus b. If we assume this as a minus b, so multiply by a plus b, so that we get a square minus b square, and a square minus gives b square. What does it give? X minus 2 minus 4 plus x. So x this will be, so we are multiplying this by x minus 2, this plus, this is minus, this is plus, we say it is conjugate. So this we are multiplying, so this denominator also we are multiplying, numerator, and after multiplication this becomes 2 into x minus 3, and here also we are having this x minus 3, means what? We can cancel it out. You can cancel it because x tends to 3, x is not equal to 3, it is having some non-zero value, so we are cancelling this. and then we get this one, root over x minus 2 by root over x minus 4 divided by 2. Now we are having non-zero limit here. So this is 2, this is also, we put 3 here, so 3 minus 2 is 1, this is 4 minus 3 is 1, so 1 plus 1 it is 2, so this is 2 by 2 it is 1. So this is the way that defines limits when denominator is 0. We are multiplying by a factor such that we have a factor which can be cancelled out. So we are getting this x minus 3, which is same as this one. We can cancel it out. This one, we are calculating this, simplifying this, then it is x into, so denominator is x into x minus 2, the numerator is x minus x plus 2. This is also this, so it is x minus x into x minus 3. This will come here, denominator, then it is, this is x minus 3, this is x, it is twice x minus 3, so this is twice x minus 3, this is x minus, so this is 2, means what, after simplification of this we get this function. Now we see what can be done. So twice x minus 3, x minus 2, so this x is now going, because x tends to 0 only, this is the determining factor. So when x cancels out, then we get non-zero denominator. So x tends to 0 means we have some value here, non-zero value, because this x goes, and we simplify it. So we put here, this is minus 3, this is minus 2, this is minus 3, minus 6, so answer is this one. Similarly, x tends to 3, so this is 0, x tends to, if we write here 0, this is 0, this is also 0. Now we simplify it. After simplification, this cancels out, x minus 3 cancels out, means what, this factor goes, so we get x tends to 3, so we have non-zero value, so it is 1 by 3. Then this one, so denominator here is 1, so we write this one, 1 into root over x plus 1 into root over x, means what, we are writing conjugate of this, and this gives us x plus 1 minus x, so x goes, so we are having this one. Here x tends to infinity, because if we make here infinity, then we cannot have value here, but after modification, some modification, we get this value. So this goes to infinity means denominator is infinity, denominator is a very large quantity, so this limit is 0. Then number 7, you see 1 minus cos twice x by x square. So 1 minus cos, so this is trigonometric result, so this is 2 sin square x by x square. It is 2 into, so sin x by x that we have got in the previous case, so we are multiplying this, sin x by x, this is sin x by x, so this limit is 2, this limit is 1, this limit is 1, so this is 2. Then this one, here it is x square, here it is x, so it is 2 sin square x by x. So here this limit is 0, because no x is here in the denominator, so value is 0. Then tan x minus sin x, we are simplifying this to get x, this is x cube, it is cos x, this is sin x minus cos x sin x. After simplification of this, then what we are having, so sin x by x, sin x taken common, sin x by x, this 1 minus cos x, so 1 minus cos x by x square, and cos x it is separated. Then 1 minus cos x, it is in terms of 2 sin square x by 2, 2 sin square x by 2. So 1, we are getting sin x by x, here it is 2 sin square x by 2, so this is 2 into sin x by 2 sin x by 2, this is x square, So ultimately we get this is 1, then the sin x by 2 is x by 2, sin x by 2 x by 2. We are making here x by 2 because then only we can write this 1. So this is 1, this is 1, this is half into this value. Then this one cot twice x by cosec twice x. We are simplifying this. Cot means cos by sine. So cos by sine, sine is, this is 1 by sine, so sine twice x comes downward. It is cos twice x minus 1. Then this is 2 sine square x. Then this is trigonometric result. This is x, this is 2 sine twice x is 2 sine x cos x. So 2 sine x cancels out. Then 1 sine x is sine x by x, this one, and one by cos x. So this limit is 1, cos x it is, this denominator is 1, so it is minus 1. Then sin thrice x by 5x. So sin thrice x by 5x we need to write like this, because this doesn't have a result. This angle must be equal to this same. So this is thrice x, so we are making here thrice x. So we are writing it 3. So we are dividing by 3 and multiplying by 5. So dividing by 3, multiplying by 5. So it is thrice x, then this 3 goes, this 5. So this is 1 now, and it is 3 by 5. This one is x degree. We always take the this x as in terms of radian. So in radian only we can. So we are converting this to radian. So radian value is pi by 180 by x. We have to multiply by this. Then to make it equal, this is this pi by 180 we have to make here also pi by 180 into x. Then we are dividing by pi by 180. And answer is this one. Then this one is 3 sin x minus 4 sin cube x by x. So this is also same, sin x taken this 3 sin x this is the result, sin thrice x, this is trigonometric result. So sin thrice x by x, so multiply by 3 and divide by 3. Sin thrice x by thrice x, it is, so this value is 1. So these are also some examples. Then this is x tends to pi by 2. X tends to pi by 2. It is 1 minus sin x, 1 minus sin square x. So we are cancelling out. It is x tends to pi by 2. It is 2. So these are some examples of this. And this limit, this is a result. This result is some results we are having. So one is say limit sin x by x. This we have deduced. This is 1. Then one result is there, limit of 1 by x, x tends to infinity. This is 0. Then one result is there, limit e to the power x minus 1 by x when x tends to 0. This limit is 1. Another limit is limit, this is a to the power x minus 1 by x, x tends to 0. This limit is log of a to the base e. Then one is there, limit log of 1 plus x to the base e by x, x tends to 0. So this limit is 1. this limit is 1. So these are some limits. We are not deducing these things, but we should know these values. So this problem, so 3 to the power x minus 9 to the power x, it is of the form a to the power x. So we are writing like this: 3 to the power x minus 1 by x. So we are subtracting 1, and this is adding 1. So 3 to the power x minus 1 minus 9x plus 1. So after simplification we get this. So we are applying this one. So this a, so this is the result. This is, so a to the power x minus 1 by x, so limit is log of a to the base e. So a is 3 here, so it is 3 to the base e. This is 9 to the base e. Then log of m by n, it is 3 by 9, so it is 1 by 3. This one, this result, e to the power x minus 1 by x. So e to the power 6x minus 1, then e to the power minus e to the power thrice x plus 1. So this is the result. So e to the power 6x minus 1, this is minus e to the power thrice x minus 1. So after simplification we get this. Now to apply this one, we need to write here 6x. So this is 6x into 6, we have to write here. So this limit is 1 and this limit is 1. So this 6 is coming, this 3 is coming, so it is, this is 1 into 6, 1 into 3, so it is 6 minus 3, it is 3. Then this we see e to the power 5x, 6 to the power 5x minus 1, 2 to the power thrice x minus 1. Then sin x is there. So what we do, we divide this by x, then sin x by x. So this is 6 to the power 5x minus 1 by 5x into 5, and this is sin x by x. So this is by sin x, this x. So this is the value for this. Now these are standard limits. So this limit is 1, not 1, this is a to the power x. So this one is log of a to the base e. So log of this is log of 6 to the base e. This is log of 6 to the base e into 5. This limit is 1 minus this is 3. This limit is 1. This is log of 2 to the base 3 to the base e. 3 log of thrice x log of a. Sorry, this one is 2, not 3. Log of this is 3. This is 2. A is 2 here. This is 6 here. So this is 2, not 3. This value is 2. This is 2. So it is 5 log 6 minus 3 log 2. So this is also same. X tends to 1 here. X tends to 1 means we write 1 plus h, where h tends to 0, so that we can have this formula. This formula we are applying. So it is log of 1 plus h. So x minus 1 is h now. So log of 1 plus h by h. Base is e here. This x we are taking downward. So this limit we know it is 1. So 1 by 1 is 1. Next. So these are also some value. We are rationalizing it. This is x, so that we can have this value as log of 5, and this we are rationalizing it again, multiplying by the conjugate. So this can be simplified. So this is standard value log of 5 to the base e. Now this is 4 plus x minus 2. So 4 will go, remains x. X is cancelled out here, and we can have some value here, non-zero value. So it is 4 into log 5 to the base e. So this is sin cube x is x cube. So this x cube we are making this, so that this is x cube, and we have this one. So these are the thing. Then this is examples of continuity. So for to examine continuity, these functions are given. So this is, so at x equal to 1 we need to have the continuity. So x equal to 1, so this is to the left side of 1 it is different function, to the right side of x it is different function. So x tends to 1 from right side this limit is 3, from right side it is 1 minus 2, it is minus 1, so they are different. Right hand limit is different from left hand limit, so limit doesn't exist, means it is not continuous. Then for what value of p, fx is equal to sin x, x less than pi p. So left first we need to find the limit. So when x less than pi, so sin pi it is 0. When x greater than pi, this value is 0. So what value of p? So we need to write the value 0 here. So this is the answer. So we write p equal to 0, then only we have f of, because f of pi, when we write x equal to pi here, this value should be 0, then only we can have a continuous function. So then number C is this, px square when at x equal to 2. So for left hand side the value is x less than equal to 2, it is 4 into p, x greater than 2 it is 3, so it is 4p. So to make it continuous we must have 3 equal to 4p. So 3 equal to 4p, so 4p, so f2 equal to 4p. X equal to 4 if this value is 3, so we must have f2 equal to 4p. So 4p equal to 3, then means what, p is equal to, value of p should be equal to 3 by 4. So these are the problems of continuity. So I am stopping this.